Hey guys, August here. Today I'm going to teach you how plate tectonics result in earthquakes and the formation of volcanoes. So let's dive right in. What are plate tectonics? Lithospheric plates, usually called tectonic plates, fit together on the surface of the earth, kind of like a jigsaw puzzle. Scientists believe that the plates float on a hot, hard region of the mantle called the asthenosphere. The movement is called plate tectonics. Surprise, surprise. Movement of the tectonic plates can most easily be observed at the plate boundaries where the plates slip and slide around the most. Most earthquakes and volcanic activity happen here. The lithosphere, it's a bit of a hard word, is the outermost layer of the earth, and it is cooler and more textured than the layer below. The asthenosphere, big word I know, underneath, is very hot and far more flexible, transferring some of its heat through convection, expelling heat by passing it through other objects. In this case, the molten rock moves towards the cooler section, welling up through the 100-kilometer deep cracks in the outermost layer, lithosphere. When the two sides of the crack move apart, the cooled rock forms new tectonic plate material. But where are the tectonic plates? The major plates are Antarctica, African, Eurasian, Australian, Pacific, North American, South American, and Nazca. There are also some more minor plates along with these ones. Some plates, such as the Pacific Plate, have only oceanic crust which is thinner and generally lies below sea level. Others have both oceanic and continental crust which come above sea level. So now that we know about tectonic plates, let's move on to volcanoes. The plate boundaries are characterized by the way the plates move, and they're associated with different types of surface phenomena. Transform boundaries. The plates move past each other, but because of friction, they cannot just glide past each other, so build up stress, which is released as an earthquake. New Zealand's Alpine Fault is an example of this type. Convergent boundaries. The plates slide towards each other. When one plate moves underneath the other, it is known as subduction zone, associated with deep marine trenches and volcanoes, some of the most explosive on Earth. Where two continental plates collide, they either buckle and compress, or one plate will go under or override the other, creating extensive mountain ranges. When two plates with oceanic crusts collide, they usually create an island as one plate is descending, subducting, beneath the other. In the last 1.8 million years, huge changes have created the landscape of today. The Southern Alps have risen thousands of meters, and volcanoes have violently erupted. In the Ice Ages, glaciers moved rock and carved out lake basins and valleys. So now, let's move on to earthquakes. Before the 1960s, it was thought that continents were set in the same position forever. Realizing the plates are changing led to new insights into our understanding of the planet and revolutionized and unified the Earth's sciences. These plate boundaries are associated with geological events such as earthquakes and the creation of mountains, volcanoes, and oceanic trenches. Most of the world's active volcanoes occur along plate boundaries. The Pacific Plate's Ring of Fire is the most active. Divergent boundaries. The plates slide apart each other, and the space that is created is filled with new crust from the magma formed below in the asthenosphere. These boundaries can create great fracture zones that are a major source of submarine earthquakes. Shear. When plates grind along each other. In some cases, the edges of the plates slide past each other, neither significantly pressing together nor pulling apart. Here, the movement can cause a lateral shear. Where movement causes horizontal displacement, it is called a strike-slip fault. The San Andreas Fault, where the Pacific Plate has been sliding northwestward past the North American Plate, provides a good example. The movement isn't smooth. The plates build up stress, which eventually releases in a sudden movement, causing earthquakes like the 1906 San Francisco event. So now that I've filled your brain with all of this knowledge, I hope you go away, tell your parents, tell your friends, tell your family. They're all gonna want to know how smart you are. Hope you learned something. Thank you for watching.